Okay, gang. This is a little video on how to do Lewis drawings of formation reactions. Formation reactions are those reactions where you take your elements and you react them together to make a compound. Now, what I want to key in on here are the Lewis dot diagrams, but I am going to include the simple particles at the end as well, like we did in class and in our homework on this very topic. But this is just an extra for review later. Now, our first chemical we're going to look at is the formation of sodium nitride. So sodium reacting with nitrogen. Now, the first thing you need to realize is we're going to write out the atoms. And just because I like to do them in color, so we're going to do it that way. It just slows me down a bit. So I look at sodium and I remember that it's in the first column of the periodic table, and therefore it has one valence electron or one outer electron. And nitride or nitrogen, has 5. There you go. So, what happens? Well, that nitrogen needs 3 electrons. Actually, let me back up a bit. And we need to suss out what each of these elements wants to do. So sodium wants to lose that 1 electron. And nitrogen atom wants to gain 3 electrons. So it's going to take 3 sodium atoms to make that guy happy, right? Now we have to remember that if we are in a formation situation, we've got basically an unlimited number of atoms to form our compound. Way more than enough, okay? So you can just kind of pull them out of midair. So 3 sodiums. And as I've said before, you can put that electron in any of the 4 quadrants. So that's going to go up there. That one's going to go up there. Now, these are the atoms. And so that's going to form a sodium ion. And in Lewis, we put square brackets around and the charge in the superscript or exponent position. Notice that with sodium, we don't show the valence electrons because that communicates, again, the idea that the electrons are lost. Whereas with the nitrogen, which is now what we call nitride, electrons have been gained. And since I'm doing this in color, we can see that those came from sodium. Now, that's not to say that every nitride that exists has sodium electrons. Electrons are electrons. They don't care. The other trick we want to do is put in subscript how many of each particle there are, and you'll notice that crossing over idea. Okay, and then to convert these to simple particles, well, we've got 3 sodiums. And your first step is to draw 1 of each. And we look and say, well, we need 2 more sodiums so that the net charge on that substance is 0. So 3 positives and 3 negatives, and we end up with sodium nitride. Now there's a little bit of nomenclature here, but ultimately I just want you to get to the Lewis dot and the simple particle and the formula. All right, and don't worry about the name for this coming quiz that counts. Now, example number 2. We're going to look at aluminum oxide. So aluminum plus oxygen. And we're going to show the reaction with the atoms. I'm showing you the entire word equation here, but we're going to just look at the atoms. The main thing here for you guys is to work with the Lewis dot diagrams, and we see that aluminum is in group 13, so we drop the 10 of the group 13, and that tells us that we've got 3 electrons in the outside shell. So since it's a metal, it wants to lose 3 electrons. And oxygen has 1, 2, 3, 4, 5, 6 electrons in the outside shell. So it wants to gain 2 electrons. Okay, so aluminum will unload 2, or oxygen actually is ripping 2 electrons off, but here's the dilemma. The aluminum started to react here. So it's going to react with another oxygen atom here. And that oxygen atom needs another aluminum. 1, 2, 3 electrons in the valence shell of aluminum. There we go there. And we've got 2 electrons left over, so it's going to be another oxygen atom that will receive those. And it's actually taking them. It's that it wants to lose, but it won't. The aluminum wants to lose, but it won't lose unless someone takes them. So we have 2 atoms of aluminum will react with 3 atoms of oxygen to form aluminum oxide. And so here's our end result. We take our aluminum, we put a square bracket around it, and each aluminum has a charge of +3 because it lost 3 electrons. Are we sure? Yeah, we're positive. And there's 2 of them, so we're going to put a 2 in the subscript position there. And with the oxygen, we're going to draw those, and we'll draw in the aluminum atoms that are aluminum electrons, I should say, that it picked up in this reaction. Square bracket, each one is -2, and we see that 3. And again, we see that Lewis dot crisscross pattern of the 3 and 2 crisscross. But I don't really like the crisscross method. So going back to aluminum, when we're doing simple particles, draw 1 of each at first. So we got -2 there. And we say, well, we got to get 2 more of those, which is going to give us a total negative charge of -6. And 2 of these is going to give us a total charge of +3. And that's going to create the scenario where we now have a total overall charge of the compound of 0. Okay, so Al2, it takes 2 of those to 0, 3 of those. And we have our aluminum oxide chemical formula. All right, so for our quiz coming up on Thursday that counts, you don't have to do the aluminum oxide or the name per se, but you have to show the atoms and where the electrons are going, and the Lewis dot of the ions, and the simple particles, and the chemical formula that would emerge from that. All right, so that's what's meant when you're asked to show the Lewis drawings of formation reactions.